Hello and welcome, my dear grade 9 elite students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's video, which is based on learning objective 16 from part 2 of exam coverage for all of you grade 9 elite students. So let's start the video today, and before we do, a humble reminder, a kind request to like, share and subscribe to the channel if you're finding the videos useful for learning and revising for your math exam. Okay, so let's solve this question now. This is based on learning objective 16 where you identify extrema of functions. These are questions 12 to 17 given in your math book or page 456. So let's see what all we have to find here. So first you need to identify and estimate the x and y values of the extrema. So remember, extrema means maximum minimum or relative maximum relative minimum. So looking at the graphs, each of them we will identify and estimate. Somewhere you have to give a round value also, because if you see we have to round off to the nearest 10 if necessary. That means for each of these graphs there may be maxima, minima or relative maxima, relative minima coming at decimal values. So there you need to just round it off to the one decimal place. Then use the graphs to describe the end behavior. So we'll also do end behavior. So let's begin with question 12 here, and you can zoom in the graph a little bit if you want to see the coordinates carefully. So there are three things we are going to do here. The extrema, that is the relative maxima, relative minimum, and then we'll move on to end behavior. So here for this question, if you see, the relative maximum means the highest point. So it's coming at this point, and relative minimum is coming at this point. So now we need the x and y values at this point. So if you look carefully for the x, you can just approximate it down. It's going to touch here. So this is x equal to -1. This is -2, this is -3. So it is a little less than -3. So I can approximate it for x equal to -2.8. So at this point you have a relative maxima. Relative maxima means it is comparatively a higher point, but it is not the highest point. Why it is not the highest? Because if you see, the graph is going up, up and up, so it may take a value higher than this. Now we come to relative minima, which is this point. So if you look carefully, relative minima is coming at x equal to 0, y equal to 4.6. So this is relative minima. Now let's look at end behavior. So end behavior is the behavior of the graph at the endpoint. So this is the behavior on the left, this is the behavior on the right. So as we are going, x goes to minus infinity because the negative side, and this is the positive side. So as x goes to, so I will just write here, on the left side of the graph, end behavior is that the graph is coming down. So as x goes to minus infinity, fx means your y, which denotes the graph, is going down, so it is going to minus infinity. And let's look at the behavior at right. So on the right, you see the graph is going up. So as x goes to plus infinity, remember I write plus here because we are on the positive side of the x-axis, and your fx is going up, so fx is going to go to plus infinity. So this is how you do the end behavior. Let me do it for one more question here. So I'm picking up question number 15. So for this question 15, if you see, there are more than one points that you see. So here the relative maxima, let's find that first. Relative maxima means the higher point, so it is coming here. So this is the coordinate. So the coordinate is approximately, we are estimating in decimal 2.7 because it's a little more than 2, less than 3. Okay, so this is the point of relative maxima. You can zoom the graph to see the point carefully, and then we'll move to relative minima. Now if you see, there are 2 points that you see are the points of relative minima. So the first relative minima occurs after -4, so it can be approximated as x equal to minus 4.4, and the y coordinate is minus 4.2. So this is the first point. The next point occurs at x equal to 4.2. That is this point now I'm considering. So x is more than 4 little bit, and then y comes out to be the same value, minus 4.2. So in this question there is one relative maxima, two relative minima. And if you are concerned about the decimal points, then let me tell you, in your exam the graph will be given in a zoomed manner and you'll be able to see the divisions carefully, so you'll be able to get these points. Let's do the end behavior for 15th question here. So on the left side of the graph it is going up, and even on the right side it is going up, so it is going to go to infinity on both sides. So on the left, as x goes to minus infinity, fx goes to plus infinity, and as x goes to plus infinity, on the right side the graph is still going up, so fx goes to plus infinity. If you want to know more detail about end behavior, I would recommend you to watch a video that I had made earlier. I will put the link in the description box. Go ahead and watch it so that you understand end behavior better. Now let's look in the next slide at the answers of all of these questions. So for these questions 12 to 13, now here I have provided you the final answers so that you can check your answer. And if you have any questions and queries, do let me know in the comment section. And that brings us to the end of today's video, which was based on extrema of functions. End of today's session, where you identified extreme of function and looked at end behavior. I hope you found the video useful, and if you did, please like, share and subscribe to the channel. Don't forget to press the bell icon so that you don't miss the notification about my new videos, especially for the next part and part 3. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye bye.